So far we've defined acids and bases as acids starting with an H and bases ending with an OH, but that's quite a generalization. So I'm going to talk in this video about the history of acid-base theory and how we have defined acids and bases. So the first definition was the Arrhenius Definition in 1887, and he said that acids produce hydrogen ions in water, and that bases produce hydroxide ions when in water. So if we added hydrochloric acid to H2O, it would ionize and separate into hydrogen ions and chloride ions. If we added sodium hydroxide, we would separate into sodium ions and hydroxide ions. So the formation of these ions was what defined an acid or a base. However, it's limited to aqueous solutions, and it says there's only one kind of base, hydroxides, but we know that ammonia is also considered a base. Now, the next definition was the Brønsted-Lowry definition in the 1920s, and it's broader than the Arrhenius definition. So acids in this case are defined as being hydrogen ion donors. So they give up a proton or a hydrogen ion, and a base is considered a hydrogen ion acceptor. So in this case, acids and bases always have to come in pairs. So hydrochloric acid is considered an acid because when we dissolve it in water, it gives up a proton or hydrogen ion, and that hydrogen ion would be accepted by water. So if we looked at the chemical equation for this reaction, you can see you have hydrochloric acid adding to water, and it forms an H3 with a positive charge. So this hydrogen, or this water has picked up a hydrogen ion, and it was donated by the hydrochloric acid, so the chloride ion is left alone. So in this case, water would be considered a base because it accepts the hydrogen ion, and it forms this charged particle called an hydronium ion. And I want you to notice here that this arrow right here points both directions. So this is a reversible reaction, one that can go forward but also backwards. And that will be important in the next video when I talk about acid and base strength and weakness. Alright, so why is ammonia considered a base based on the Brønsted-Lowry definition? So if we put ammonia with water, ammonia is actually going to accept a hydrogen ion from the water. So remember, if you accept a hydrogen ion, you're considered a base. So you form this ammonium ion, and then hydroxide is left. So again, this would follow the Brønsted-Lowry definition and is inclusive of ammonia being a base. Alright, so the next definition is called Lewis acids and bases, and he focused on the donation and acceptance of pairs of electrons during a reaction. This is the broadest of the definitions, and it says that a Lewis acid is an electron pair acceptor and a Lewis base is an electron pair donor. But this is the most broad of the definitions, and it says that acids don't even need to have a hydrogen.